Okay, so for 8-2, we're talking about reflections. 8-1 was translations with capital T. For reflections, we use capital R. So a reflection is a flip across a line of reflection. Each point is equidistant, that means equal distance from the line of reflection. Okay, so the function notation of this is we have the capital R and whatever line it's wanting us to reflect over. Okay. Now, if the line is on the reference sheet, you're going to want to use that, okay? And it will tell you whatever shape or point to reflect over that line. So now when we look at the reference sheet right here, we can see that when it reflects over the x-axis, it goes from xy to x negative y. Now that negative means to change the sign. So if I were to take this point, I would say reflect over the x-axis the point -3, -4. Okay, and I'm going to call that point P. Okay, my P prime, so that would equal P prime, image, would just be X would stay the same, so it would stay -3, and my Y would change signs. This negative does not mean that Y has to be negative. It means whatever Y was, we are going to change the sign. So we change that to a positive. Okay? And this doesn't mean X has to be positive. This doesn't mean X has to be positive, Y has to be negative. That means X stays the same, Y changes sign. That's a very important thing to note here. Same thing here. Over the y-axis, the x changes signs, but the y stays the same. Now, over the line y equals x, notice something different here happens. We go from xy to yx. That means we switch the x and the y. And then over the line y equals -x, we switch x and y and change the sign on both. Okay, so these are pretty rare occasions. Oftentimes, it's the x-axis or the y-axis. And sometimes it won't say x-axis or y-axis. It'll say over the line y equals 0. The line y equals 0, think about the coordinate plane. This is our x-axis, and this is our y-axis, right? The line y equals 0, where y equals 0, well, that's the x-axis. And the same thing with the line x equals 0. That's the y-axis. So we got to remember that. Over the y-axis, that's the same as x equals 0. Y-axis equals the same as that. So now, what about when the line's not on the reference sheet? So there's only 4 lines on this reference sheet. And there could be an infinite possibilities of lines it could reflect over. So one thing to keep in mind, it might say reflect over the line x equals 2. So the way that we do that, x equals 2, x is a vertical line. The way we graph vertical lines is we go to that spot on the x-axis, go 1, 2, and then we draw a vertical line. I'm drawing it in dashes. I'd highly recommend always doing your line of reflection to be with dashes. Also having graph paper handy, or at least paper with some lines on it, would be helpful here. Or over the line, if I was to reflect over the line y equals, let's go, -2. I would go to the y-axis, go to -2, and then draw a horizontal line. Okay, so those are just what those 2 lines look like. It's how to graph vertical and horizontal lines. And then I have this little graph paper, and this is why graph paper would be so handy, or at least looking at it on a graph, maybe using Desmos if you're at home to graph the line. You could say graph the line y equals 1. You could plot your point, and then you could count. So that's an option if you don't have graph paper. I really like drawing it out because it helps me see it a lot better. So first we draw our xy coordinate plane. We plot our point. So in this case, it's wanting us to reflect over the line y equals 1, the point 3, 4. So I'm going to plot my point. That's the second step. I plotted my point 3, 4. My third step was to draw my line of reflection. So my line of reflection was at y equals 1. So I go to the spot y equals 1, draw a dashed line. Dashed lines just help us to not mistake them for the x-axis. And I call that line y equals 1. Now, the most important step, and this is how we actually reflect over this, we're not reflecting over the x-axis. We're reflecting over this line. And because of reflections, it's a flip across the line of reflection. Each point is equidistant. They are equal distance to the line of reflection, which means if I count 1, 2, 3, that's how far away this point is from the line of reflection, I can go 1, 2, 3 past the line of reflection, and that is my new coordinate. Notice I'm not 3 below the x-axis. I'm 3 below my line of reflection. The x-axis is just there for help us to identify this point is at 3, -2. Okay? It's not our line of reflection. We count to the line of reflection and we go the same distance past it, which is very important. And then we plot the point and name it. So that's P prime. It's plotted at 3, -2. Okay? I will have graph paper in class. Like I said, if you don't have graph paper at home, using Desmos, Desmos.com, Desmos.com. It's a calculator, it's a graphing calculator that can help you with this, to help you visualize it and see it, okay? But using the reference sheet and using this for lines that aren't on the reference sheet is going to be your key to success. Let's look at some example problems. So in our textbook, it says reflecting across a point across a line. So this is the one I literally just showed you. This is the point 3, 4. We reflect it. It's 3 away, 3 away. Next up, if we take a point or a triangle and reflect it across the y-axis. This is still where I recommend, just like if you watched my translation video, where I recommend you draw the 3 columns, okay? Made that column kind of small. Let's make a bigger column. The first column should say pre-image. The middle column should be our rule, and the last column should be our image, okay? So these 3 columns can really help us. So we write our pre-image of those points. Oh, it already has them written out for us, so we don't even have to figure them out ourselves. We have A is at -3, 4. B is at 0, 1, and C is at 4, 2. We didn't even have to figure those out. And it wants us to reflect, so we write the rule right here, reflect across the y-axis. That's what it says right there. Now, when I look at my reference sheet, when I reflect over the y-axis, that means I change the sign on x. My bad. Change the sign on x, y stays the same. I like writing that right here. Change the sign on x, y stays the same. That way I know what I'm doing. So now for my image points, A prime, B prime, C prime, I know all I have to do is change the sign on all these x's and keep it the same on all the y's. So the opposite of -3, 3, and y stays the same. 0, there is no -0, so it just stays 0, and y stays the same. And 4 flips to negative, and 2 stays the same. So notice all my y's stayed the same, and all my x's change signs, except for 0 doesn't change signs. And then if it asked us to graph it as well, we could then plot those points and graph it on our picture. Now, if it asked you to write a rule based off of a picture, that's as simple as, hey, I can say to get from triangle 2 to triangle 4, my rule could be as simple as it's a reflection across line K, triangle 2 equals triangle 4. That is a reflection rule, okay? That's how we write it. Reflection, capital R, what line you're reflecting over, what you're reflecting, and what the product is, okay? So that is what 8-2 reflections is all about.